Hello and welcome in. Mark here, aka the Markster. This is video number 71 in the FreeCAD series. So today a user on the forum has this question about making a minor edit to an imported step file. Now often you can find step files online at various places, and you can then import those step files into FreeCAD, make some minor modifications, and print them out. Now often if you get these from manufacturers, they will have some intentional errors in the file just to keep people, I guess competitors, from using them. And sometimes I suppose errors could be in the original object accidentally. Often users will create a step file in another CAD package such as SolidWorks or Fusion 360 and then want to put it into FreeCAD, so they'll export as a step, import into FreeCAD, and you end up somehow along the way errors occur. But anyway, this user has this box and he wants to cut a circle, a circular hole in both sides of this box. And that's what this video is going to be about today. So let me show you which version of FreeCAD I'm using. We'll start there. This is 0.19 revision 21.1.25. It's one of the Conda bills. And this is from May 19th, which today, at the time of this recording, this is now 10 days old. So there's probably a newer version out there. So here's the file he uploaded, or one of them. And this is the cylinder that he wants to cut into the side of it. Notice it's 6.35 millimeters, 2.5 millimeters height. Another question he had was when he imported this in an earlier version of FreeCAD, he got separate components, one for the lid, one for the bottom, one for each of these screws, etc. So I'm going to go ahead and close this file and import his step file. Now notice when I do the import, I'm getting this hierarchy that he got in his earlier version. So let me explain why this is happening. So we can hide the lid and see inside the box, and you see the screws separately. Alright, so why am I getting separate components and he got one compound of all these objects? The reason is if you go into the edit menu, preferences, import export, come over here to step format. We have an export section, we have an import section. The first option here says enable step compound merge. If this is checked, the object gets merged into a single compound. So the user evidently has this checked. So undo that, do the import again, you'll get separate components. Alright. Now the first thing I like to do when I import a step file is to check for geometric errors, and we do that with the check geometry tool. And the part I'm most interested in is the bottom of this box. So I'm going to select the box bottom and run the check geometry tool. And we've got some errors. And many of these are related to the text that is inlaid in the bottom of this box. So we can eliminate some potential future problems by removing that text. But there are also some other problems, and it's related to these edges here. The chamfer or fillet, whatever that is, has some problems. So presuming we would like to, or the user would like to print this out on a 3D printer, and he will be exporting this to a mesh, an STL file, importing that into a slicer to create the G code and then print that on his 3D printer. At least that's how I would do it. So let's test that out. We go to the Mesh Design Workbench, select the box. In the Meshes menu, select Create Mesh from Shape. And I'm just going to use the standard default settings. Then I'm going to hide the part object, which hides all these other objects. So only the mesh is visible. Right? And just like we have a check geometry tool and part workbench, in the mesh workbench we also have an analyze tool in the menu here. So let me select the object and then evaluate and repair mesh. Now here we have our mesh selected and some information about it. And we have all these different tests that we can run for orientation, duplicated faces, etc. Self-intersections. And at the bottom here, all above tests together. So if we press this Analyze button, it will run all of these tests for us all in one go. And we see we have an error here, 66 folds on surface. And all of these appear to be related to that text. If we go to wireframe mode, we can see that there are no red and yellow error indicators, little crosses that it puts on anywhere but at the bottom of there. So it looks like we can ignore the errors along these edges, but we do need to correct these errors here, possibly. You might still be able to get a good print, but I'm going to go ahead and show you a way to eliminate that text. Let me delete this mesh, show the original box, and let's go into Part Design Workbench. I'm going to select the box object and create a body. Well, it's not let me do it because that's belongs to another part. Alright, let's drag the body into that part and drag the box. Let me make this bigger here. Drag the box into the body. Not cooperating. Delete the body. Let's try again. Let's remove the box from the part. And now select the box and create a body. Now we have what I was trying to do. So what we have, let's hide all the other stuff. So the only thing visible is the body object and the base feature inside. So what it did was it created a base feature based on this box. And now we can proceed to do some other operations. So I'm going to select this face, create a sketch. That's a bad example. Let's do it to the XY plane instead. And now we could attach to this face safely because the base feature is never going to change. We're not going to change this box, and so our sketch is not going to become detached from that face. But there's no need to do that because I'm just going to pocket through all to get rid of that text. And now I'm going to do something that most will consider a no-no. Go to Part Menu. Let me go to Draft. Might not need a clone. Let's try it. Let's see what's going to happen. I want to defeature this hole. Now I could simply pad the same sketch to fill the hole in. Let's see if we can defeature this. Yeah. And the reason I have a grid, I went to Draft Workbench. Let's turn that off. Alright, so I'll defeature that hole. Select the defeatured object and create a new body. So we can continue using part design. And this time I'm going to attach a sketch to this face. And I'm okay with that because I know this base feature is not going to change. And I'm going to create some links to external geometry. So I want this circle that I'm going to draw centered diagonally to this rectangle here, defined by these 4 points, these 4 vertices. So let's do some links to external geometry to these 4 points. And this was a method suggested by another user named OpenBrain, and I thought it was a good one. So, except I don't think he wanted me attaching to that face. Now I'm going to add some construction lines across the middle here. Now let's get out of construction mode. Add a point. I'm going to put the point on this edge and then select the point on this edge and constrain it to also be fixed on that one. So now it's in the center. And now we can put our circle attached to that center. And recall this radius was 6.35 millimeters. and he wanted a depth of 2.5 millimeters. So we can pocket it 2.5. So it doesn't cut all the way through, but I'm going to pre-assume that was the intention. Of course, if you want it all the way through, you can just change this to through all instead of a length type, through all, and that will cut all through the entire object, should that be desired. But if it's not desired, we can go back to the length and cut it 2.5. So we can do the same with the other side. We can map another sketch here, or we can try to do a mirror of this feature using the mirror tool here. Let's try some of these different planes and see if we get what we want. The base XZ plane is the appropriate one. We can ignore those arrows. So now we have it cut 2.5 millimeters from the outside edge into each side of the box. Now let's go to mesh design and see if this is going to be a valid object. Still have some poles on surface, and those are switch back to as is here. You see there's a little protuberance that we left. That's causing a problem. So it's a good idea to test, because if you just exported this as a mesh, put it in your slicer, and maybe it starts printing, and when it gets to this point it goes crazy and you end up wasting all this time printing this box, and you get to the top and you have a failure. So how do we fix this? Well, if you want to cut all the way through, then you won't have this problem, because you could just defeature this. But I don't see how to defeature it here. might have to move that circle up just a bit to avoid this problem. We can adjust our sketch attachment offset. Let me make that viewable so we can see. Why are you moving back? Oh, because of these links to external geometry. So what I'm going to do is delete that constraint. This constraint here. Move the circle up. And let's put it 1 millimeter higher. It's gonna be too much. I also want this vertical with that one. Let's see, 1/4 of a millimeter and see what that looks like. That's more than necessary too. So we're not going to need to move it much at all. .1 millimeter I think is going to be adequate. Now let's try to make another mesh and test it. Okay, no errors. Now there is a little problem of leaving this thing flapping, which might or might not be a problem. So if you wanted to correct that, you should be able to extend that upwards a little bit. Create some support for it if you wanted to. Oops, wrong one. Another bad practice, attaching to the face. But again, we're not going to be making any more changes to this base object. So that created a little bit of support for that tab. And you still have your full, no you don't, you don't still have your full 2.5 millimeters. Here's another trick. Make a sketch on this one. And so that would be still providing the full 2.5 millimeter depth and also supporting this middle piece if you wanted to do that. Notice I selected up to face and selected this face as my destination. And now we need to do the other side, which we could also mirror over. And that was the XZ plane. Now let's see if we can go to mesh design. Now you have different options here. So one of the advantages of creating your mesh first and then exporting it is you have all these options. Now you need to install GMSH if you want to try this one. It has a nice feature that if it seems to be hanging, you can kill the process right here. So that's neat. But I've tried this a few times. It has to be installed and you have to tell it. So download and install, or just all you have to do is extract a GMSH executable and then tell FreeCAD where it's at. Mine is in drive E in this folder. But I've tried this a few times and the circles always come out as polygons for me, and every time I've tried it. So I don't like it for that reason. If you don't have circles in your object, then that looks like a good one to use. But NetGen works great. It's slow. Standard is fast. And I found that if you change this surface deviation to a smaller value, you get polygons with more edges on your circle. You see all those edges that polygon has, all those faces. It's very coarse. Depending on how good your 3D printer can produce nice round edges. So we can try it again, and this time 0.01. And I'm going to hide that first one. Notice how you have a lot more. I can't go over it because it makes it yellow, but in the inside of that circle there, you have a much smoother transition. You have more faces to that polygon. Let's go back to the original and show you the difference. You see that? That's the original with the default settings. And this is the last one. It's much smoother. Depends on your printer and how good it's going to be able to print down to these levels. And it went pretty fast. So let's test and see if we still have errors. So no errors, so we're good. So this thing would be now ready to go. I would export. You probably would choose the better looking one. Export mesh from here rather than selecting a body and going here and exporting. If you go here and export, you don't get the options and you don't get to test the STL. You don't get to test the mesh before exporting it. Or you could bring it in afterwards and run that same check on it. That would work too. It's probably using just the standard default. I've also found, while we're off topic, that if I export I can choose wavefront OBJ, I can choose STL, or I can choose AMF. And each of these works. I haven't tried alias mesh, but each of these works with my slicer, which is Cura. The wavefront OBJ, the AMF, and the AST. And there was a time when I tried to do something as an STL and it failed, and I exported as AMF and it worked. So if you're having trouble, that's another option. But I really believe if you make your mesh first, run this analyze tool on it, and then export from here, you should be good. Alright, well that's going to be it for this video. Thank you for watching, and as always, have a great day.